In this lesson, we're going to explore nets and surface area. You will draw two-dimensional models for three-dimensional figures and find surface area. Why is surface area important to car manufacturers? Have you ever wondered why cars have evolved from boxy shapes to sleeker shapes with rounded edges? Car manufacturers use aerodynamics, or the study of wind resistance, and the shapes of surfaces to design cars that are faster and more efficient. For our first example, they'd like us to sketch a rectangular prism, 4 units long, 3 units wide, and 2 units high using isometric dot paper. Step 1 is to draw the corner of the solid 2 units down, 4 units to the left, and 3 units to the right. Next, we'll draw a parallelogram for the top of the solid. Step 3 is to draw segments 2 units down from each vertex for the vertical edges. And step 4, connect the corresponding vertices. Use dashed lines for the hidden edges. Shade the top of the solid. Note that right angles of a prism are 60 degrees and 120 degree angles on isometric dot paper. This is to show perspective. If you cut a cardboard box at the edges and lay it flat, you will have a pattern, or net, for the three-dimensional solid. Nets can be made for most solid figures. This net is a pattern for the cube. It can be folded into the shape of the cube without any overlap or gaps. Which net can be folded into a triangular prism if folds are made only along dotted lines? A triangular prism has 2 triangular bases and 3 rectangular faces. If we look at choice A, this net has only 2 triangles for the bases, but only 1 rectangle. B can be folded. This net has 4 non-overlapping triangles and a square for the base. It folds into a rectangular pyramid. Oops. This net has 4 squares and 1 triangle. It's not going to fold into anything nice. This net has 3 adjacent rectangles and 2 triangles. The triangles are adjacent to each of the shorter sides of the middle of the rectangle. Each base and face of the prism is represented. This is going to be our correct choice. Okay, honestly, it's nice to have some three-dimensional figures that you can look at that I have in the classroom. So let's look at another one of these that we can do in a multiple choice fashion. Now, I kind of already gave this away. Which could be folded into a triangular pyramid? Well, we had a square pyramid that showed up as one of the choices before. This, you could fold it, but you wouldn't have a bottom. It would overlap. This guy could fold up these triangles and leave this guy as my base. That guy would work. This would also fold, but it's going to make a square pyramid because the base is a square. We're going to have extra pieces here. Yeah, it's not a foldable one. Okay, so the one that's going to work is B. It's a triangular-based pyramid. That's very useful in visualizing the polygons that make up the surface of a solid. A net for a tetrahedron QRST is shown at the right. So there's our base triangle RTS, and then those are the faces, other faces. The surface area is the sum of the areas of each face of the solid. Add the areas of triangle QRT, triangle QTS, triangle QRS, and triangle RST to find the surface area of tetrahedron QRST. It can be helpful to draw on dot paper. Let each unit of the dot paper represent 1 unit of measure. When the numbers are large, let each unit of dot paper represent 2 units or 10 units or whatever you need. Draw a net for the triangular prism. Our base, or bottom, it's actually the bases are triangles. The bottom of this is 4 by 6, so there's our 4 by 6. And they showed the altitude or height of the triangle is 1.5. Okay, now we're going to have to figure out the hypotenuse of that little right triangle to find out how far these should go, that I already let it be drawn in. So we need to find the hypotenuse of a right triangle. So we're going to do 2 squared plus 1.5 squared equals c squared. So 4 plus 2.25 equals c squared, 6.25. And square root of 6.25 is 2.5. Okay, so another little Pythagorean theorem, but that gave us the length of these two sides. Actually, it's a width, and this would be 6. Now here's the real question. Use the net that we just drew to find the surface area of the prism. I don't know if theirs would be easier to read than mine, but here it is typed in the same dimensions we had. So we just need to find the area of these 1, 2, 3, 4, 5 different polygons and add them together. So we have 3 rectangles and 2 triangles. They have a rectangle's length times width, so 6 times 2.5 is 15, plus 6 times 4 is 24, plus another 15. Area of a triangle is base times height divided by 2, and the 4 and the 2 cancel out well. So I've got a 3 and another 3. And so all together I have 60, and the units were centimeters, so it's going to be square centimeters because it is area. Every three-dimensional solid can be represented by one or more two-dimensional nets. The area of a net of a solid is the same as the surface area of the solid.